there, and we were giving him outfits, and we saw that if he had 5 pants and 4 shirts and 3 socks and 2 gloves and 1 hat, that the total number of outfits he could make would be 5 times 4 times 3 times 2 times 1. And there's a shortcut to write that. It's called 5 factorial, because that happens a lot when we're doing counting. And probability is all about counting. So we can do that on our calculator. Let's look at the shortcut there. So there's a button there. I'll go math, go left, and number 4 is the factorial button. Oops. I have to put the number in first. So I'm going to go 5, math, and then go left, probability, and then hit enter. And there's my 5 factorial, 120. So if I take 5 times 4 times 3 times 2 times 1, that equals 120. And so we just call that 5 factorial. That's what factorial means. All right, and these are the keys that you press to get there. So we'll practice doing this a couple times. Go ahead and practice that, and then you can check with me when you're done. So when you've got the 6 factorial, you would get 720 on your calculator. Now we have, factorial is just like any other thing. It can be part of a fraction. So you would set up, you would do alpha y equals to get a fraction first. All right, so go alpha y equals, and there's my fraction. And I've got 7 factorial, so let's go 7 math to the left, number 4. And then I'm going to go to my denominator, and I'm going to divide by 7. Okay, so we treat it just like a regular number. And look, since we divided out the 7, what was left was 6, 5, 4, 3, 2, 1, so it was 720. So this was also 720. All right, because 7 factorial was 7, 6, 5, 4, 3, 2, 1. And then we divided by 7, so that goes away, and you get 6 factorial, which is 720. All right, so now we're looking at the next one. You can get a lot of stuff going on here, so go ahead and practice typing those in, and check back with me. Okay, so when you do that, you get 495. All right, and that's just getting a fraction and then practicing typing in the factorials. And then it turns out that 0 factorial, when you put that in, is 1. All right, and so that is good to know. Now we're talking about permutations. So those were all, when we talked about the outfit, right, the fundamental counting principle. Alright, so now we have 3 people, and they're in a row, and we're going to do the same idea. We have Abigail, Brendan, and Cassie. So there's Abigail, Brendan, and Cassie, and we're looking to see how many different orders they can sit. Okay, so if I have Abigail in the first chair, then I have 2 choices for the second chair. I could put Brendan or Cassie. All right. Then I would have 2 choices. If Brendan's in the first chair, you can have Abigail or Cassie. And if Cassie's in the first chair, you can have Brendan or Abigail. So I first had 3 choices. All right, I could have 3 people to choose from, and then once someone's sitting down, then I had 2 choices, and then now I really only have 1 choice, because if Abigail's in a chair and Brendan's in a chair, then Cassie has to be in the 3rd chair. And if you have Abigail, Cassie, then this has to be Brendan. Brendan, Abigail, this has to be Cassie. Brendan, Cassie, this has to be Abigail. All right, and so this is called a tree diagram, and in statistics, we use it to count the possible outcomes. All right, and so you can see here, you have 1, 2, 3, 4, 5, 6 possible outcomes, because I could have A, B, C, A, C, B, B, A, C, BA or CAB. All right, so we have 6 possible, and those are called outcomes. All right, that is because order matters. If Abigail's in the first chair, that's totally different than if Brendan's in the first chair. All right, so for permutations, order matters. And this is how you get there on the calculator. All right, so we're talking about different orders. So order matters if it's a permutation. Okay. So let's say I wanted to let's see if we could get that 6 doing this mathematically. I'll do 3, and this is called 3. I had 3 people to choose from. It's a permutation because order matters, and I'm putting all 3 into a chair. So I'll do that on my calculator. All right, so you put the number that you're choosing from. So you have 3 people, and it's a permutation, so I'm going to go to math, and that's a probability thing, and it's number 2. And then I'm choosing 3. I'm putting all 3 in a row. So 3P3. All right, and so that gives us 6. All right, and because what that is the formula is you have 3 factorial, however many, right? That's how many ways you can put things in a row. And then you divide by 3 minus 3, right? These numbers, you subtract them. All right, and so that would be 3 factorial divided by 0 factorial. Well, and we said that is 1, so that would be 6 divided by 1, which is 6. Okay, so now we have our 12 skiers, all right, competing in the final round of the Olympic freestyles. So it says how many different ways can they finish? So that means order matters. It makes a difference if you're third or first, if you're first or last. All right, so especially if you've been doing all that training. So how many different ways? Well, you have 12 skiers who could get first. And once someone has gotten first, then you can have 11 skiers, right, who could get second. And then you have 10 who could get third. And then you have 9 who could get fourth. So this is the counting principle, right, is involved in this permutations. But because we've just had these all in a row and we're putting them in order, that is called a permutation. 3 times 2 times 1. All right. Now that's a lot to write out. So we have shorthand. All right, and we just write, that would be 12 factorial. All right, so I'm going to go ahead and I'm going to, oopsie daisy. I'm going to go ahead and make that be 12 factorial. All right, and then notice that is equal to, I'm taking 12 things in order, and I'm putting all 12 things in a row. And let's see if those are the same on our calculator. All right, so we typed that in our calculator, and notice it is the same. 12 factorial, all right, is this big number here, right? So that's 12 factorial right there, and this is 12p12 right there. All right, so now, okay, that you can arrange 12 things, and that's why we use the shorthand with the 12p12. And again, that comes out from the formula. You get 12 factorial divided by 0 factorial, which is just 12 factorial. Okay, so now we have, in part B, we're getting silver, gold, silver, and bronze. So we don't care about the last 4th through 12th place. We're just looking at 1st, 2nd, and 3rd. So now you have 12 for 1st place, 11 choices for 2nd place, and 10 choices for 3rd place. All right? So what that is we have 12 things, 12 people. Order matters because you're getting gold, silver, or bronze, right? They're very different. Order matters, and you're only taking 3 things. All right? So with our formula there, that would be 12 factorial divided by 9 factorial. So notice that's what happened. There's our 12 factorial, but the 9, right, 9, 8, 7, 6, we got that got divided out because we only wanted the first 3. Okay, and so if we look at that on the calculator, go 12p3. All right, you want to practice typing this in. So 12 over the probability, it's a permutation, and then 3. And we'll hit enter. So 1320. Okay, 1,320. That's a lot fewer ways, right? That makes a big difference. Okay, so now we have our homework assignments. We're arranging in 5 different classes. Then we're deciding how to complete the different ways to complete them. Well, order matters because it depends if I do my history first, right? There's 5 choices. Let's say I decide to do history first. And then I decide to do algebra 2 because that's really, really important. And then I decide to do my geosystems. And then I decide to do my, what is left? English, write my English paper. All right, and then I have 1 choice left for that last assignment. Whatever's left over, that's what I've got to do. So that is 5 factorial ways to do that. All right, I had 5 things, order matters, and I'm arranging all 5. 5p5, okay? And I think we did that already. That was 120, right? And then now we're not gonna do 2 assignments, okay? We're gonna take the 0 on 2 of our assignments. We just don't have time, okay? So that means I'm gonna have 5 choices for the first, the second, and the third, right? But I'm not, that's all I'm gonna do is 3 assignments. And so that would be 5 choices, right? 5 things, and I'm taking them 3 at a time. I'm choosing 3 things to do. But order matters, so it's a permutation. All right, and so that would be 5 factorial divided by 2 factorial. All right, and then if we do that on our calculator, we get, so that was 5. It's a permutation, order matters. So we go to P, so number 2. And then we're doing 3 of our assignments. So we're picking 3. And so that would be 60. Okay? So that cut our choices different ways in half. All right? So now we're looking at words. All right? And so if you rearrange the letters, it's going to be a different word. So order matters. All right? So this would be a permutation because order matters. All right, well, how many letters do we have here? Ooh,